This video is for lesson 14-2 about medians of a triangle. Learning goals are to determine the point of concurrency of the medians of a triangle and to use that point to solve problems. So in the previous lesson we had this situation of the three guys that were going to make a nature reserve on a piece of triangle-shaped land. Along with that there was a treasure map and they were following clues to locate the treasure. So let's continue that situation about finding where the treasure is. The next two lines of the poem give the clue. Stand at the place where two medians meet, and the rest of the treasure will be under your feet. So this has this vocabulary term, medians. Over here in the bottom corner, we see the vocab word median defined. A median of a triangle is a segment from a vertex to the midpoint of the opposite side of a triangle. So the previous lesson we discussed what the word altitude was. It also was a segment from a vertex, but it touched the opposite side at a 90-degree angle. A median is a segment from a vertex that touches the middle of the opposite side. So question 1, carefully draw all three medians on triangle AGC. Name the coordinates of the points where the medians appear to cross. Do they appear to be concurrent? So here in this picture we have the one from the other day that had the altitudes drawn, which intersected at that position right there, called the orthocenter. Let's redraw this triangle on this other grid, and I've done that in green ink, and this time we're going to draw the three medians. So medians touch the midpoints of the opposite sides. So looking at segment AC here, I think the middle of that segment is about right there. And the way that I found that was to notice that if I go over one, up two, over one, up two, over one, up two, like this, that I could do that 6 times. And so I went over one, up two 3 times, which took me to that spot. So when we connect from there to the vertex opposite from it, point G, this brown line that we're drawing is a median, and it splits this segment into equal parts. Okay, side CG, I think the middle of that side is about right there. The way that I found that was I counted these diagonal units and divided by 2, and then it ended up in that spot. So connecting vertex A to that dot, we get this right here, which splits this up into 2 congruent pieces. And finally, the median that comes down from point C is going to touch that bottom of the triangle in the exact middle. Well, it is 36 units long, so going to the 18 right there would be the halfway point. So we'll carefully draw down towards that dot. And that separates the bottom into congruent pieces. So the brown lines are the medians of the triangle. Do they appear to be concurrent? Well, yeah, it kind of looks like they do. It looks like all 3 of them touch right there in that position. It says name the coordinates where the medians appear to cross. I think that is maybe, let's see, that's 10, 12, 14, 16, comma 8. That looks to be about 16, comma 8. Okay, next one. Use concepts from algebra to prove or disprove our answer to item 1. Number 2, write the coordinates of the midpoints of each side of the triangle and label the midpoints as follows. So the midpoint of AC, this one here, we're supposed to call that H, and that's at 6, comma 12. The midpoint of AG, the bottom, we're supposed to call N, and that is at the 18, comma 0. And the other midpoint we're supposed to call point E, located at 24, comma 12. Number 3, determine the equation of median AE. Show your work. So let's find median AE. It's this one here running uphill like this. We want to find the equation of that line. It looks like the slope goes up 1 over 2, up 1 over 2, up 1 over 2. So the slope is 1/2, And a point that we know for sure is on that median is 0, 0. So 0, 0 is a point on that segment, and its slope is 1/2. So we can use the point slope formula. Y minus 0 equals 1/2 times x minus 0. Simplifying, we get y equals 1/2 x. Okay, number 4, determine the equation of median GH. So median GH is this one right here, and it looks like the slope maybe goes down 2 units and then right 5 units, ending up at that dot right there. So negative 2/5 for the slope. And we also know for sure that this point at 36, 0 is on that line. So 36, 0 is a point on the line, and the slope is negative 2/5. So we have y minus 0 equals negative 2/5 times x minus 36. We can simplify this and get y equals negative 2/5 x plus, and then we would have, let's see, 2 times 36 is 72/5. Number 5, determine the equation of median CN. So CN is the one that comes from that top vertex downwards to point N. Its slope appears to be, looks like it's down 4 over 1, and then down 1, 2, 3, down 4 over 1, down 4 over 1. The slope is negative 4, and it for sure touches here at point C, which was 12, 24. And so its equation is y minus 24 equals negative 4 times x minus 12. And then simplifying, we have y minus 24 equals negative 4x plus 48. And then one more step, y equals negative 4x plus, and then 48 plus 24 is 72. Number 6, determine the coordinates of the intersection of segment AE and segment CN. So I'm going to take the equation for AE and for CN. The equation for segment AE was the y equals 1/2 x. And for CN, the equation was the y equals negative 4x plus 72. We can solve this using substitution or combination method. I'm going to use substitution method because y is equal to 1/2 x. I can substitute the 1/2 x in place of the other letter y. And we would have 1/2 x equals negative 4x plus 72. Add the 4x to the other side, and we have 4.5 x equals 72. And then divide both sides by 4.5. X equals 16. Once we know the answer for x, we can put that answer up here into that first equation and find that y would equal 1/2 of 16, which is 8. Writing this as an ordered pair, 16, 8. By the way, 16, 8 is where we thought that that point of concurrency was located. Number 7, verify that the point of intersection is also on GH. So let's take our equation for GH, which we had figured out in problem 4, and substitute in our ordered pair that we think is the right answer. So this was our equation from problem 4, and let's substitute 8 in for y and the 16 in for the x and see if this works. Negative 2 times 16 is negative 32 fifths, and then the plus 72 fifths. Adding these together, this is 40 fifths, and 40 fifths does equals 8. This checks. Number 8, explain how the algebra demonstrates that the three medians are concurrent. It shows that 16, 8 is a point on all three median segments. Number 9, Al wants to be certain that the medians are concurrent for every triangle. Use geometry software to draw a triangle and its 3 medians. Then drag the vertices around to change the shape of the triangle. Do the medians remain concurrent? We're not going to use geometry software. Let me just tell you that no matter what shape the original triangle is, when you draw its medians, yes, they will be concurrent. And question B, that point of concurrency is always inside the triangle. The second part of the buried treasure is located at the centroid of the triangle. That's the vocabulary word for the point of concurrency of the medians. So we had the word orthocenter yesterday for the point of concurrency of the altitudes, and today we have the vocab word centroid for the point of concurrency of the medians. Number 10, what are the coordinates of the location of the second part of the treasure? That's 16, 8. It says go back to the drawing and label that point R. So this dot right here inside the triangle, we're supposed to call it point R. The centroid's location has a special property related to segment lengths. Use geometry software to find these lengths. So let me save some time here and tell you that with software that quickly measures segments, these are the results. Number 13, compare the lengths of collinear segments. What relationship do you notice between the distance from the vertex to the centroid and the distance from the centroid to the midpoint of the opposite side? The distance from the vertex to the centroid is twice the distance from the centroid to the midpoint. Let's go back to the picture and take a look at this. As an example, the distance from A to the centroid at point R is twice the distance from R to get to the E. Or let's look at another median. The distance from C to that centroid is twice as long as the distance from the centroid to the median. The same is true for that third median. This relationship is called the centroid measure theorem. Here it is one more time. The centroid of a triangle divides each median into 2 parts so that the distance from the vertex to the centroid is twice the distance from the centroid to the midpoint of the opposite side. The centroid is also called the center of mass of the triangle, or the balance point of any triangle. Number 15, create a triangle out of construction paper, find the centroid, cut out the triangle, and then balance it on your pencil point. Let's not take the time to do this. But theoretically, if you're very accurate with your cutout and you put the paper perfectly on the pencil at the centroid, the triangle should balance there in space and not fall over. Here are some check your understanding questions, so I'll pause the video. In this lesson, we found the point of concurrency of the medians. This was called the centroid.